Hi, we are Josh and Jani, and we are here to demo our paper improving prosody using Tacotron with GMM attention. This is our end-to-end pipeline with an encoder, a synthesizer, and a vocoder. The encoder and the vocoder are taken from the original author's work, whereas the tacotron.py, which has the attention in the synthesizer model, is our original work. In the original paper, LSA or location sensitive attention were used, whereas we are using GMM attention as our model. Uh, Before demoing, I need to give you a little bit of talk about our data set. So originally we had to download our data set, download and save our data set locally, which is a half a terabyte s- size of data. After pre-processing, this folder were created with a synthesizer in it, synthesizer folder in it, which had the pre-processed audio embeds and melts. So we use this folder, this data for our training purposes. So to quickly show you how a training starts is like we run this synthesizer train.py and we give it a name which is basically the new run ID. So I'll create a new folder, GMM Synth 4, which will create a new folder in my locally and where the synthesizer.pt will get saved. I'll give you a demo like how it is getting saved and how where we are actually getting our model from. Yeah, this will take a little bit of time, but we are definitely not going to run the entire training. Also, it's just to show you how the training starts and how where the models are getting saved. So as you can see, the training has started. The loss definitely looks bad, but it goes down. So I'll show you what's happening in my local is inside the synthesizer, we have a saved model, and this is where the new run got added. And as you can see, we have these are yet not created. We have this folders done, but I'll show you one created file folder. So GMM Synth 1 is our last completed training run. And as you can see, I can show you plots of the mel spectrograms. So this is the target and this is the predicted mel spectrogram. And you can see that they're pretty close together because the loss is pretty low. This is just one sample. And now to start our demo, we need to put all the synthesizer, encoder, and vocoder model um, in one place. So what we did was we created a saved models and inside a folder where all the three models are saved. The encoder PT and vocoder PT is from the original author, whereas the synthesizer.pt is something which we created in our last completed training run. Now let's give a demo. I'll stop the training. So we have a demo toolbox done by the original author again, and we will just run this to show you how we are synthesizing our new audio. So let's upload some author's voice, some audio.
That's an excellent question, and I thank you for it. I think it's great we live in a town
So this is our original voice, and I'll now quickly synthesize and vocode.
Welcome to the toolbox to begin loading utterance from your datasets or record one yourself. Once its embedding has been created, you can synthesize any text written here. The synthesizer expects to generate outputs that are somewhere between 5 and 12 seconds. To mark breaks, write a new line. Each line will be treated separately.
This is our synthesized voice. If needed be, we can also export this voice and save it somewhere. We are not doing it right now. So this is our new synthesized model. Hope you like it. Thank you.